Okay, everybody, let's start. Start what? Developing center of mass. So this is the chapter 9 of our book, Center of Mass, Linear Momentum, and Polarizing. So the first part of the chapter Linear Momentum, we have already covered it. Now we'll start with the chapter called Center of Mass. Okay, so let's start. Center of Mass. Okay, so what is this basically? Center of mass. So, first of all, scientists made this kind of things to make the study of kinematics a lot easier. And I hope you guys have watched the lectures of kinematics. But what is kinematics? Okay, let me show you. The branch of physics concerned with rest and motion is called kinematics. So this is the term which we are talking about. That means rest and motion. Okay, so to make this easy, why do we even need to make this branch a lot easier to understand? Like we already know, the ball is square, that means the time motion just like this, which is at theta. So initial velocity u, range is r, and the maximum height reached is h. T is time of flight. So this is a basic case. I'm just taking an example basically. Here is some kind of things which we will learn. Okay, so this was the case if it was a ball. But what if it is this kind of object? So then how will we discuss it like this? It doesn't make any sense, right? So to understand this and to convert this body into this body, to understand its motion more simply, is called center of mass. So that's why we use this. Okay, looks like everybody is clear with this part. So why do we need center of mass? Now let's see how do we study this chapter and this part of chapter. Okay, so this chapter is basically divided into 3 parts. What? 3 parts? I don't get it. Oh, you will get it definitely. Discrete, particle, system. 2, particle, system, and continuous body. So these are the 3 parts. These 2 are very easy, so we will first discuss this and then discuss these continuous bodies, because there are again a lot of parts like semicircular ring, semicircular plate, uniform rod, but that is not much. We will try to do this in one lecture, but let's focus on the first part, then the second part of the system, and then third. Okay, so should we start with discrete particle system? I hope you guys understand what is center of mass and why do we even study this. Let's Do you remember what is discrete particle system? No, right? Go and check it out. I won't tell you definitely. Okay. Discrete particle system is kind of a system in which there are lots of particles and like they move everywhere like this. You got it. Whatever it is. This is that. Why? This is that. Now I'm telling you, what is this kind of system even? It is the kind of system which we can choose on our own because it is called three-dimensional geometric system. That is three-dimensional Cartesian point. And we all have understand this in mathematics lectures that we can choose our own coordinate. Don't go very much into mathematics as well as physics currently. Okay, so discrete particle system in which there are lots of particles. Like if there is this particle will be going here, and we have to study that where are both of them going. Could you say over here and over here? Definitely not. We got to find its center of mass and then study its motion. Definitely we will understand about motion of center of mass in the last topic chapter. For now, let's just focus on this. Okay, so we basically get it. How do we get it? That's what I am telling you. The formula of the coordinate of center of mass, okay, might talk it out. The formula of center of mass or in discrete particle system is like RCM is equal to summation of I is equal to 1 to n mi ri upon summation of I is equal to 1 to n mi. First of all, you guys note this down, and then I will explain that what are the terms in it. Okay, everybody got it? I may note it down, so let's understand this. RCM. What is this? Coordinate. Coordinate, that is x, y, z. I will tell you what is this. And then this summation sign so that we have to add them all. And that means product of mi and ri, and again ri is x, y, z coordinates. And here it is given I is equal to 1 to n. That means that it varies to particle to particle, that number of particles. Sign so I is equal to 1 to n summation. And this is the total mass summation for this. That means we just have to add all the masses. So I think this might be clear to you. And now let me explain it to you. Why do I write RCM? Definitely this is a very good question, but RCM definitely represents x, y, z. That means here we can derive three formulas which we could remember easily. That is XCM is equal to summation of I is equal to 1 to n mi xi by summation of I is equal to 1 to n mi. Now this is clear to you. This is the first formula. Now what is YCM? YCM is equal to summation of I is equal to 1 to n mi yi by summation of I is equal to 1 to n mi. So this is the second formula. Alright, now let's just erase this part and write the third formula. So let's create particle system. Okay. to 1 to n mi zi by summation of I is equal to 1 to n mi. So if you don't understand the terms of those formulas, you can remember this. And many people have doubts that what does this mean? Zi. It shows the coordinate and we can calculate it. That means we can easily do the multiplication with mass. There is no such a kind of unit barriers. So this was all about discrete particle systems. Okay, I hope you wrote this part down. Alright, you guys wrote it down. Let's move forward. So the first part was discrete particle system, which is complete. Now let's start with two particle system. Wait, what? Is this two particle system? That means in this there will be just two particles and not two bodies. And this is just a simple case of discrete particle system. Yeah, oh yeah. This is, you can say, case of discrete particle system. The separation be R and let's have one mass be here. So it's going to be R1 and it is going to be R2. Alright, COM, this is COM and it is given that 2 is greater than 1. First tell me, is this figure visible to you? Is this figure visible to you? Alright, many people are saying it is not visible, so should we continue with this? Let's make a bigger one. Whoever can understand it, then they know it. Okay. This is whatever we get. This is M1, this is R. Now could anybody strike this here? Yeah. Looks like yes to me. Here, what do we basically have to do is that R1 is equal to M2 R1 M1 plus M2 and R2 is equal to M1 R by M1 plus M2. These were some special formulas which you find in the history of our book, which I'm teaching you definitely. Okay, now we could calculate it with 3 particles, but it is not very much necessary. So now let us just make some formulas of the coordinate. XCM is equal to M1 x1 plus M2 x2 upon M1 plus M2. YCM is equal to M1 y1 plus M2 y2 by M1 plus M2. And let's see. I write Z in this way, so don't be confused. Is equal to M1 Z1 plus M2 Z2 upon M1 plus M2. So these were some special cases of discrete not discrete particle, two particle system. So you guys could note this part down. Till then I'm just clearing the area for you. Alright, it is done. So we have completed the two basic parts of this chapter. Now there is just a central mass of composite bodies. So let's move on that. What is these composite bodies? We don't need to work our minds on it. Just remember that composite bodies are bodies we have to discuss. So I think that there is three cases. Semicircular wire, case 1. This is the one. Here we are going to learn about some materials. Semicircular plate. And this is the whole area. Okay, semicircular wire, semicircular plate, etc. etc. Not etc. etc. And a rod. Let me write it. Uniform semicircular wire. This is uniform semicircular plate, and this is uniform straight. So you guys check with the book. Does this part match? Okay. I also checked. It is all given in the book. So let's start. Its radius is r. Also let its radius is r2. Okay. So over here, RCF will be 2, R of what? 5. And over here, RCM will be 4 by 3 into R by 5. So these are very important formulas. I don't want to teach you more unless you guys can just follow it. I know there are lots of letters like cylinder, cyclomatic cylinder, and etc. Uniform straight rod. Okay, so let its length be L, and it is total length, and it is clear that this is straight or not like this, and then you are telling us how you do this. You might learn this in our classes, but this is not in our syllabus. So let this length is M and it is uniform, then its R 3M will be L by 2. You might be thinking that why didn't I give you derivation of all this formula? Well, there is no need. Definitely for JE, and so there is no need of derivation. I mean, yeah, if you got time, you can do this. But these are one-shot lectures, so just don't do this. So, but definitely for JE point of view, there is no need of derivations, and because there is no any use. So why do we do extra things? So these are the formulas, very important one. And in a CMR, there is a lot of questions even on this, so you guys will practice. Okay, so should we move to motion of center of mass? Is everything alright? Oh, right, there is nothing wrong with it. Let's move to the motion of center of mass. Let me understand that. Define center of mass. Then what do we do to solve the questions? Here it is taught. Alright. I need to get the cluster all the time, that's why. Alright. Let's move to motion of center of mass. Motion of center of mass. Alright. So how do we basically find it? Because in the motion lectures, kinematic of the same accelerator is given in chapter 3, and as far as I remember, it is also in chapter 7. So how do we basically calculate it? First, we need to find it. Because from velocity we can derive speed, then acceleration. Alright, from acceleration, what do we get? It is the change of velocity. What do we need more? Force. Force net. And then kinetic energy. I differentiated it because there are both different types of formulas. Like for velocity we do VCM vector is equal to m1v1 vector plus m2v2 vector plus m3v3 vector plus this. It goes on and m1 plus m2 m3 plus this. That's how it goes. Same for acceleration, you can guess it. ACM vector. CM represents acceleration of center of mass, it won't be confused. It is like m1 a1 vector plus m2 a2 vector plus m1 plus m2 plus. Now what is force net? It is kind of simple. F1 plus F2 plus F3. That means the force net is adding all the forces. And we got to take care of sign convention, like if wall is falling like this, then we make the Cartesian coordinate system. This is plus, this is minus, and this is plus, this is minus. So we got to take minus sign for adding it. So that's how we continue. And same for kinetic energy net. Kinetic energy 1 plus kinetic energy 2 plus this. That's how it goes. So basically, should we move forward? Well, that's what it is. We have completed center of mass in just the one short lecture. So now we will move to the third part of our chapter, center of mass, linear moment of collision, which is collision. So I hope you liked this video. So bye.